There is a moment in science when we think we've finally started to understand what's going on. And then, right at that moment, everything changes. 3. Atlas is one of those objects. At first, it seemed familiar. An interstellar comet arriving from beyond our solar system, passing quietly through our cosmic neighborhood, leaving behind a handful of interesting data points, and then moving on. At least, that's what we thought. But the longer we observed it, the less our models held together. The numbers stopped behaving. The activity appeared at distances where, according to everything we know, it simply shouldn't. And then, at the exact moment we needed clarity the most, we went blind. The sun itself blocked our view of 3I Atlas, just as it entered the most critical phase of its entire journey. So the question was no longer, what is 3I Atlas? The real question became, what did we miss? And is this object really what we thought it was? The name 3I Atlas began appearing everywhere in scientific discussions. Not just because it was a rare interstellar visitor, but because it refused to behave like a typical comet. It changed. It reacted. It repeatedly violated expectations built into our standard models. At a certain point, even researchers had to admit, we were looking at something not yet fully understood. Before disappearing behind the sun, 3I Atlas left behind unmistakable clues. Ultraviolet observations revealed a surge in hydroxyl radicals, the direct fingerprints of water being torn apart by sunlight. But the real problem wasn't the presence of water. It was the distance. At nearly 3 astronomical units from the sun, temperatures should still be extremely low. According to conventional models, water shouldn't be sublimating at anything close to this rate. And yet, 3I Atlas was releasing tens of kilograms of water per second. That forced scientists to stop and ask, are we missing something fundamental? Or does this object possess a structure unlike anything we've studied before?
Then 3I Atlas vanished. Not because it ceased to exist, not because it left the solar system, but because the sun completely overwhelmed every Earth-based telescope. For astronomers, this was the worst possible scenario, because this was precisely when 3I Atlas should have been at its most active. If something extraordinary was going to happen, it would happen on the far side of the sun. And the question became unavoidable. Did we miss the most important moment? Fortunately, Earth wasn't our only vantage point. Far from our planet, spacecraft designed to study the sun became silent witnesses. Using artificial eclipses, they blocked the solar disk and saw what Earth could not. When the data was finally compiled, one thing was clear. 3I Atlas had transformed. For months, its brightness increased steadily, exactly as expected for a comet approaching the sun. But after crossing a critical threshold, the increase didn't just continue, it exploded. Not a gradual rise, a sudden jump. To shine that brightly, the object had to eject an enormous amount of material in a very short time. In other words, 3I Atlas was losing mass at an alarming rate. And that led to a disturbing hypothesis. Was it falling apart? If 3I Atlas was fragmenting, this wouldn't just be an active comet. It would be an unprecedented event for an interstellar object. And it would mean we were witnessing its final moments.
Some models suggested that to generate such extreme activity, the active surface area would have to increase dramatically, something that usually happens only when a comet's outer shell breaks apart, exposing its interior. But then, 3I Atlas reappeared. And the shock was this: it was still intact. No debris trail, no chaotic cloud of fragments, no signs of catastrophic breakup. This forced scientists to confront a more unsettling question. If it didn't fragment, if it didn't disintegrate, what produced such extreme behavior? Suddenly, the details once dismissed as odd demanded attention again. The sunward-pointing jet, the subtle non-gravitational acceleration, a trajectory that seemed almost too clean. Some argued that if the observed mass loss couldn't fully explain the acceleration, alternative mechanisms had to be considered. The idea of artificial propulsion entered the discussion, not as a conclusion, but as a stress test for our assumptions. But science doesn't stop at intuition. When radio observations were added, when hydroxyl signals were detected penetrating dense dust clouds, the picture sharpened. The water was real. There was a lot of it, enough to generate a powerful natural rocket effect. In other words, 3I Atlas didn't need intelligence to behave strangely. It only needed a long history and an unusual structure. And that's where a deeper mystery emerged. Chemical analyses revealed that 3I Atlas didn't resemble comets from our own solar system. Its carbon dioxide content was extraordinarily high, suggesting it had been chemically cooked by cosmic radiation during billions of years drifting between stars. This wasn't a pristine relic. It was a profoundly altered object. Even more surprising were traces of metals like iron and nickel. When water interacts with such materials, heat-producing reactions can occur, building pressure beneath the surface and triggering violent outbursts. This mechanism may explain the brightness surges, the jets, and the behavior that made 3I Atlas appear almost intentional. Now 3I Atlas is moving away from the Sun, carrying irreversible changes. In the future, it will pass Jupiter before leaving the solar system forever. But what matters isn't where it's going, it's what it's left behind. How many interstellar objects like this have passed unnoticed? How many messengers have we missed? And do the rules we rely on in astronomy need to be rewritten? 3I Atlas doesn't give us all the answers, but it forces us to ask better questions. And perhaps that's what makes the universe so endlessly fascinating. If you found 3I Atlas fascinating, then the questions it leaves behind may be even more compelling. Because 3I Atlas was not the first interstellar visitor, and it certainly won't be the last. Out there, in the space between stars, countless other messengers may be passing silently by, each carrying stories science has only begun to uncover. If you want to continue exploring the mysteries of the universe, the objects that challenge our understanding, and the moments when science forces us to rethink what we know, stay with Ultimate Space Secrets. Because every new discovery doesn't just give us answers, it reminds us how much more there is still left to discover.